This is going to be video 1.112, and it's going to be reflections, or not reflections, composition. Composition of two reflections across parallel lines. So let's start out with a couple of parallel lines. We'll have L sub 1 there, and we'll have L sub 2. And let's make these lines and not just segments. Let's get a point P. Let's see. What we want to do is reflect P across L sub 1, then L sub 2. So we want to reflect P across L sub 1, then across L sub 2. In other words, and we're just going to write this mathematically. In other words, this is M of L sub 2. Now we use M for mirror and not R for reflection, because R for reflection could also refer to rotation, so that may get confusing. So this is what we want to do mathematically. To reflect P across L sub 1, let me scroll down just a little bit. So to reflect P across L sub 1, because it's a reflection, it's going to be the same distance, just on the other side. So we're going to have it a distance of x, and that will be P prime. So that is equal to M of L sub 2, and that's of this P prime point right here. I'll just do that all in yellow. Too many colors will get confusing. M of L sub 1 of P, which equals M of L sub 2 of P prime. So that's where we're at right now with the P prime. I'll do that in green. We then need to reflect across L sub 2. So let's get a distance here. We know we're going across 2x. Let's go across and say this distance is D. So the point that P gets reflected to, we'll draw an arrow here, and then we'll do another one in red, going way up here. So how far is P prime from L sub 2? Well, it's x plus D. So we can have this as D and this as x, and point P prime prime ends up being x plus D across. So that equals P prime prime. And then we want to find the distance from P to P prime prime. Well, from here we have D minus X, well, so it would be d minus x to get this short distance. Let me do that in blue. We'll have d minus x is that distance. Then we'll say plus x plus d for those distances right there, which turns out to equal 2d.